Hey, how's it going? Today, we're going to go over two sum. This is one of the first problems that you can work on for lead code, and I feel like this is kind of just, well, to be honest, it's a good thing to learn. Like, I feel like it just really introduces you to the world that you're about to get into, and the amount of frustration and stress that can come along with doing so. All right, anyways, so for the purpose of this video is mainly just for those who want to learn how to approach a problem. I feel like there are a lot of videos out there that target more of just solving the problem with like an explanation, but none of them really go into how to think about a certain problem. Um, So that's what I want to accomplish here, and hopefully it holds value. All right, so going into it, this is two sum. This is a problem where, so you're given an array of integers nums, and they target or integer target. Return indices of the two numbers that such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. All right, so we just read that out. Let's why don't we just take some notes about what things we should be looking out for. So we're checking nums for two numbers that equal a target, equal target. Um, we'll have exactly one solution, so we don't have to worry about um, it not working, and then use each element at most one time. All right. So those are like the main things that we want to clarify, or these are like the main points of this problem that we want to solve. Um, and so initially, I feel like if I had first viewed this when I was initially like coding and stuff, I'd probably do something similar to, okay, do why don't I write it out actually? So we'd have for let I is equal to 0, I is less than nums dot length, I plus plus. I probably do something like this, and then we'll have for let I is equal to 0. I guess no. Also j is equal to I, and j is less than nums dot length, j plus plus. This is sort of just like I'm iterating through the array, right? And then once I have a number, I'm just gonna check the rest of the other numbers. Um, if you look at it at first glance, you would probably notice like, oh yeah, I mean I don't have that yet, so why don't you do this too? Let nums I plus nums j is equal to target. And then we're going to return. What do we return? The indexes. So we'll return an array of I and j. Cool. And you'll probably notice at first glance this won't work because I have this set at I. But this is kind of just like how I would think I would have solved it, tried to solve it at least, given like I was much earlier in my career. And if you look at this solution, the idea it's it's iterating through, so it runs like n squared time. So it's not very optimal. Um, so then now I go into like the patterns. Like what am I looking at? So once I have a number, I'm looking through the rest of the array. Um, but what I notice here is, okay, so if I have a 2, what do I need to get target of 9? I need a 7. So we're going to look for a 7, right? And then say if I have a number of, I don't know, like 5, I'm going to look for a 4. And this process just keeps continuing for each number. And if you don't have an extended knowledge of data structures, it's very important to understand each of them, and what they can each be used for. Because if your knowledge is limited to arrays, it's going to be very difficult to solve these kind of problems in more optimally. Um, so I highly suggest you look into that. There are plenty of other videos that will cover it. I don't really plan on covering it unless, I mean, the large number of requests come in for it. Um, but yeah, moving forward. So then, if you think about what I said before, I said if you find the 2, you need to find the 7. If you have a 5, for example, you need to find the 4. So we can sort of store our result as we move forward to determine whether or not we can compute to this number, or which indexes would compute to this number. So if I, for example, instead of using 2 for loops, I can make it into where I use a map. This would be a map, new map, hash map, and this hash map will contain contain like key value pairs, where key is the number we're looking for, and the value can be the index. So that really simplifies the logic a lot more. So now we can do it. Let I is equal to 0, I is less than nums.length, I plus plus. We're going to iterate through each index, and then we'll do a if map.has nums I. But we're not looking for nums I here. We're looking for target nums I, right? Because we want to do the difference. And if we have it, then that means we can return those 2 indexes. So in this case, we can return what is it? We're returning this here. This will be a get, so this one will return the index of the first number, or I guess the number that we're looking for, and then this would be I of the index that we're on currently. Otherwise, we're going to do map.set. What do we want to set here? We want to set the number that we found, right? So that way we can find if it exists. So say I find the 2 initially. I'm going to set the 2, and what index are we on? We're on the index of I. And then next time I come around, say I find like a 6, for example, then I'm going to set that. And then once I get to a 7, I will go, okay, hey, does map have 9 minus 7? And 9 minus 7 is 2. And since we do have a 2, we'll have the index as well. So if I do a map.get the target minus I, this will be 2. And this will be the index, or target minus I, nums I is 2. And then map.get of 2 will give us 0 because of the previous setting that we had. And then I will be whatever index we were on, which would, I mean, index I is, or nums I is 7. So that way we'll have the 2 indexes. And then what about like, what's it called? Where we can't use the same element twice, right? So this one would solve it because we're iterating through the array, and every time we move forward, we're using the values prior to it. And say for some reason, I mean, there are duplicates, right? Say we have a 7 and a 7 and a 14 for our target. Then we have our 7, we'll find that. It'll be, what's it called? Our map will have a key of 7 with a value of 1. And then if a 7 is here, then we'll have, okay, so do we have we'll have 7. So we'll do 14 minus 7 for this case. And that'll be 7. So we'll look for map.get of 7. And that'll be on index of 1. So there we would return index of 2 and 1. And that would be the result. Yeah, so I hope that makes sense. Like this initial for loop is just to sort of give you an idea of what, and it, like I would think initially, right? Like it's a very naive solution, but it really I guess displays how you could solve something using very basic fundamentals, but when you start to expand your knowledge to a level where you're learning about different data structures, such as like trees, linked lists, stacks. I mean, it keeps going on and on. You can leverage them into a way where it works better for you. And I have learned throughout my experience that just going through these problems does not help unless you're aware of what tools you have available to you. Um, and many times I feel like I come up with a solution, and when I look at the editorial, it contains other solutions that are much better, much more easy to comprehend. And the thing I notice a lot is, oh, they're using a different data structure, or oh, they're using extra variables to store other results. And it's just, yeah, it gets very annoying to run into those kind of things. So just being better prepared before you run into, or before you start doing these problems, is something I highly recommend. um yeah, I will continue to do more of these videos. If you liked it, please subscribe, like, leave a comment, whatever your heart desires, and I will see you for the next video.